In previous videos, we went through the basic terms of computer networks and how workstations can connect to the internet. Now we have to put all these pieces together to see how an integrated network operates. A network architecture puts network pieces in layers. The layers define a model for the functions or services that need to be performed. The layered architecture enables each layer to work independently but at the same time interact with other layers. Network architecture is a reference model that describes the layers of hardware and software necessary to transmit data between 2 points. Reference models are necessary to increase the likelihood that different components from different manufacturers will converse. The two most common architectures known today are the TCP/IP protocol suite and Open System Interconnection or OSI model. The TCP protocol suite is a working model that is currently used on the internet, while the OSI is more of a theoretical model for teaching purposes. The TCP/IP protocol suite was created by a group of computer scientists in order to support a new type of network, the ARPANET, being installed across the United States in the 1960s and 1970s. The goal was to create an open architecture that would allow all networks to intercommunicate. The TCP/IP protocol suite, as shown in this picture, has 5 layers: application, transport, network, network access, and physical layer. The physical layer deals with transmission media such as different wires and wireless waves for sending and receiving data bits. The network access layer or data link layer handles the devices such as switches and hubs that help PCs access the network. The network layer is responsible for routing a data packet from the source all the way to the destination. The transport layer makes sure the data received at the very end of a transmission is exactly the same as the data originally transmitted, but it relies upon the network layer to find the best path for data to take from one point to the next within the network. And finally, the application layer provides services to the end user, and all networking applications such as web browser and email applications work in this layer. The OSI protocol suite, on the other hand, has 7 layers: physical, data link or network access, network, transport, session, presentation, and application. Application layer is equivalent to TCP/IP's application layer. Presentation layer is responsible for the final presentation of data, including code conversion, compression, and encryption. Session layer is responsible for establishing session between users. Transport layer is equivalent to TCP/IP's transport layer. Network layer is equivalent to TCP/IP's network layer. And data link layer is responsible for taking the data and transferring it into a frame with header, control, and address information and error detection codes. And the physical layer handles the transmission of bits over a communication channel. It includes voltage levels, connectors, media choices, and modulation techniques.